he might have forgot to. I'll text him.
No, he didn't forget. I was bugging him the other day. You can catch him.
I'm gonna run to my truck, grab a bottle of water real quick.
I got water here.
You sure?
Yeah.
Maybe it hurt to get your head to that road.
Yeah.
Good.
Ours was going to use.
I need to just do that. So it's not like. It's actually paid right now.
Hey, wait a couple more minutes. Yeah. Smoky was gone, right?
Afternoon.
Okay.
Went out there.
Question. Reference that you did here. To a section, and I don't know where it's at.
Master plan, we need to do anything that time, make copies or anything.
No, we have a link. So in here, I mean, if they want to review it, they can put in some sort of copy available for them. That's the way it went out. There should be a link on our website.
Is that going to be
Yeah,
here?
those things you can't see them.
I think you might want to do a little
Here,
better.
I put my glasses on so I can see.
Just say,
Who knows?
No matter which one of those, won't be certain anything there.
Just gotta get one.
No.
Is it gonna be like a place for older people or?
Yeah, it's probably about moving assisted living or some sort of.
Is that what they do at home?
I was gonna
Yeah.
say, they already switched it over, then they can.
Right, they're not
Say
done
they go,
anything.
no.
Yeah, they're not working.
Right, I mean, that just means the purchasing name off through. That's what the name's all different, but all that.
Is it just all the land with it too, or?
Yeah.
Okay.
all right, let's call this work session to order. Clerk's not here today. This is for the Marathon Township Board of Trustees. It's a work session. It's with regards to large-scale battery storage. I'm going to do roll call. Dennis Hogan here. Lori Hollis.
Here.
Michelle Coultas is absent. Bill Sickner. Justin Church, absent. Okay, let's have allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Hey, Nate. So, the only on the agenda today is to talk about, or have discussions about large-scale battery storage. With us, Mr. Tom Sutton. I'm going to let him introduce himself, but at our public hearing on the change to the solar ordinance and the new battery storage ordinance, somebody brought up his name, and I did some research on YouTube and watched one of his videos where he was giving a presentation to Gratiot County. I don't recall the year for that.
It was last year.
I was thoroughly impressed with the information that he provided and the answers that he gave. That I asked him to come here and talk to our fire department and our board and maybe give us some insight that can help us in the years to come. So, you want to say anything more, Mr. Sutton?
Sure, I'll stand up for introductions and then I'll probably sit down for the presentation. My name's Tom Sutton. I'm the owner and president of Sutton Technical Services. I retired, I don't know, 4 years ago now from a director at a technical training school at Columbiaville Community College, where we do workforce training development. And my company focuses on safety compliance, workforce safety training, qualified electrical worker. But my real passion lies with the fire service. I spent 22 years as a paid on call. I retired as a lieutenant out of Columbiaville Township. I still do work with the technical rescue teams. as an advisor for high angle rescue, confined space rescue. And one of the things that I do for clients all around the country is to provide fire department tactical training on batteries that may be moving into their municipality. And how are they going to deal with it, right? There's a lot of questions out there. There's such a need across the country that I also have co-authored a national fire training curriculum that's going through accreditation with the National Fire Academy currently. And I was just telling Dennis, I leave at 4:30 in the morning for Missouri. Missouri State Fire Academy has adopted that, so I'm doing a train the trainer for all of their state fire instructors. And so a lot of times I get called out to an event just like this. I'm here to help you understand the codes and the standards, or what you might be looking for on an emergency response plan review from the fire side. I can talk a little bit about ordinances, but I try to stay out of that realm. I'll give you the information, the facts. The one thing that I see a lot around the country is there's a lot of noise. And it's hard for people like you in your position that have to make a decision to get through all the noise and get down to the facts and the data and the standards. And that's what I'm here to help you with. So I think maybe the best way to proceed is we'll start with what I call a BESS 101, a Battery Energy Storage System 101. What is it? Why is it being installed? What does it do? And then we'll move into some of the safety regulations, the lessons learned from historical events, and we can finish up with some authority that has jurisdiction questions, fire-related questions, and I'll just kind of open it up. Okay, does that sound fair? Cool. I'm sorry I'm a little raspy. I think it's because I was in the Caribbean last week. My body is revolting. All right, so what we'll do is we'll talk about what it is, some of the typical equipment that will be installed in a project, why it's being deployed. Some of we're going to spend a little bit of time in the system design and the safety systems, the testing and the hazard analysis that has to go with that. And then I'm just going to open it up to some questions and answers. And at any time, stop me. This is a work session. This is not a formal presentation. We can make this very conversational if we need to. So when we look at battery storage, there's really three buckets. We have consumer electronics. Everybody have a phone? You have a lithium-based technology battery inside of it. Does anybody have medical devices implanted? Or know of anybody who does? Lithium-based technology is what runs that inside their body. Okay? Cordless drills, cordless saws. Anybody have any of those? DeWalt's, Milwaukee, somebody's going to sue me one of those days. Right? So we are surrounded by consumer electronics that use lithium technology. So that's one bucket. Second bucket is residential. Are you seeing any solar on rooftops, on houses, anywhere? It's more and more nowadays. Those are connected to some kind of a storage system. It could be a Tesla Powerwall, it could be an LG system, it could be just a bank of lithium batteries. And in the older days, we used to see some lead acid batteries. The problem that we run into with residential, and I'll touch on it here, and then I'm really not going to come back to residential because it's not what we're here to talk about. But a lot of times, in a lot of municipalities, there's very little involvement from the AHJ, the authority having jurisdiction. I know even in my jurisdiction down in Columbiaville Township, we're pretty big. Not every system that we ran across had pulled permits or had it done professionally. There was a lot of do-it-yourself stuff. And as a fire officer pulling up on a potential structure fire at that house, I didn't have any kind of pre-plans or locations. Where are the batteries? Where is the disconnect? Did it disconnect the way it's supposed to? Our SOP was to get heavy canvas tarps to the roof and get those cells covered, because they're producing even in the middle of the night from the reflection off the moon. So those can present their own unique challenges. That's the second bucket. The third bucket is really what we're here to talk about today, and that is utility scale BESS. It is highly regulated through all the way from the federal down to the local, with the ordinances and things like that. It's transparent. If there's a BESS project coming in, the developer has to engage the community early on, and it's a very transparent process. And then there's a lot of codes and standards. NFPA 55, I see you got the book over there, that's excellent. It's 2026 version, which is just released in April. There's also UL 9540 for Underwriters Laboratory. So those are some of the things we're going to talk about and why it's so highly regulated. There are, like I said earlier, there's different types of lithium-ion chemistries out there. The most common being used today in battery storage is what's called LFP, and it stands for lithium iron phosphate. The older systems, 5 years and back, were nickel manganese cobalts. And then there are some, like in portable electronics, like your laptops, your smartphone, that's a lithium cobalt oxide battery. We also see, like in space exploration, batteries like the lithium titanates, the manganese oxides, and then medical devices and others. So we're surrounded by the technology every single day. The change from nickel manganese cobalt chemistry to lithium iron phosphate was done specifically for safety. The nickel manganese cobalt chemistry, unfortunately, is what you see a lot of times if you search YouTube, go on the internet. Those chemistries, and we'll talk a little bit later about it, but it wasn't real stable at higher temperatures, and it would have an incident where it would violently off-gas. The reason that the industry used it is because it has a super high capacity, a power density capacity. Could be rapidly charged. It could be charged over and over 10,000 times or more in its life cycle. Unfortunately, the drawbacks to it are those events that we can find on the internet. And so the industry made the change to lithium iron phosphate, removed the heavy metals, gave up some of the energy density to do that, so it's not as highly energy density. Has a similar lifespan, actually a little longer. And this is the most popular now in electric vehicles and grid storage. It's just a safer chemistry. So why is battery storage being deployed in every state in this country in places you wouldn't even know that existed? And it's because of this graph right here. What this is a screen scrape that I happened to get lucky on the time that I was putting this together. There's two green lines here. There's a dark line and a lighter line. The lighter line is what we call cleared demand, and the darker line is what we forecast us as a consumer to be demanding from the electrical grid. The gold line is the actual demand. If the gold line exceeds either of those green lines, the grid is in trouble. This is where we get brownouts. We get damage to substation equipment, pole transformers, things like this. The grid operator's job is to operate the grid in such a way that we balance our demand with the generation at that moment in time. Up until battery storage, the grid had no capacity to store electricity. The electrons made in the generation plant to run this projector had to be made a millisecond before I used it, and it had to be balanced. If those get out of whack, we start to put stress on the grid components like lines, transformers, substations, and switches, and ultimately the grid operator has to make a decision. And here's a fun fact for you. Under the federal regulations, the grid operator has 3 seconds to react to a grid imbalance. 3 seconds, okay? And what they're triggering on is the frequency. Our frequency is 60 hertz, and if it goes, there's a critical above, like a 60.42 hertz, and a critical below, like 59.3. 59.3. If it gets out of that range, they have 3 seconds to correct it. The grid operator has to make a decision, and here's a fun fact for you. Under the federal regulations, the grid operator has 3 seconds to react to a grid imbalance. 3 seconds, okay? And what they're triggering on is the frequency. Our frequency is 60 hertz, and if it goes, there's a critical above, like a 59.3, if it gets out of that range, they have 3 seconds to correct it. The Historically, we've done it with capacitor banks on poles, big capacitor banks in substations. We used to keep what we call spinning reserves, which was generators that were either driven by coal or natural gas. We kept them kind of spinning all the time, burning a little bit of fuel, but not actually putting out any electricity. And then it was much quicker to turn them back into generation because we didn't have to bring them up from zero. But it still takes anywhere from 8 to 15 minutes on a spinning reserve to get it onto the grid. A battery can do it in 2 milliseconds. 2 milliseconds. So from a grid operator's point of view, I would much rather have battery able to be dispatched. Think about it like this. Does anybody have an uninterruptible power supply in your computer? So UPS, or you know what that is. It's something you plug your computer into, and if the power goes out, it gives you 10 minutes to go ahead and save your stuff and shut down. That's what these are, but they're for the grid. Okay? They store a large amount of electricity, and they can dispatch it or put it to the grid in 2 milliseconds.
I have a question.
Yeah,
Do you have this in a PowerPoint that you could share?
I may be able to share this.
That'd be awesome.
Yeah, I could probably share this. I probably need to clean up some notes in the background and stuff, but yeah, I can do that. Because there's probably some proprietary stuff in there.
On that good note.
Yeah, that's fine. I'd be happy to shoot one to you.
I appreciate it, thank you.
And if you look at the larger picture, this is a picture of all of the things that are on our grid right now that generate. Everything from coal to bio to nuclear, natural gas, and solar, and that just happened to be on that day. Looks like it was a fairly windy day because wind and solar were making up quite a chunk. The state of Michigan specifically, and it's not unlike every other state in the country, but Michigan specifically has mandated that coal plants be shut down. And the problem with mandates is they're unfunded and they leave it to everybody else to figure out, right? And then on the other part of that sometimes we forget to talk about, any public utility that has generation assets in Michigan, by law, has to comply with that. They have to figure out a way to do it. So what you don't see on here is battery, because battery is not a generator. Battery is storage. And it's interesting, when I go to the updated dashboard today, battery is listed, and sometimes you'll see it as a positive number, and sometimes you'll see it as a negative number in the fuel mix. If it's a negative number, it means it's charging. It's taking some of the electricity that the grid doesn't need right now, and instead of shutting off the wind turbines or turning down the power plant, we're pushing it into a battery so we can use it later. And other times you'll see it as a positive number, meaning that at that point in time, the batteries are giving up some of that stored energy to help the fuel mix go back a slide to balance demand versus generation. So that's the real large picture. The other thing that battery does is it allows all generation sources to be used more efficiently. Now, I've shown you here in this picture, there's wind forecast and a solar forecast, and that's fine. Our forecasting ability now, 24 to 36 hours out, has such high accuracy that we can predict a day from now how much reliably, like with great certainty, how much energy wind, how much energy solar can contribute to the grid. The problem is solar can only contribute to the grid during sunlight, right? So what if I can't use it all? I just have to turn it off. I can't turn off the sun, I have to turn off the solar field. Who in here is going to go get 10 gallons of free gas from somebody and pour it down the drain? Because that's what we're doing with solar right now in this country. And battery can fix that, and it is. And this is why a lot of times you'll see a battery storage facility located right next to a solar facility or put in where a wind farm is. It plays really well with those two particular sources, but it can also be standalone. It just needs a connection to the grid that can handle the amount of power that we're going to move in and out. It also, and I said, it helps us with all fuel sources, because if I can predict 24 hours ahead of time that wind and solar are going to contribute this amount of energy onto the grid, then I can tell the coal plant, natural gas plant operators they can back down that amount that following day and use less fuel. They can't do it instantaneously. It takes 10 to 12 hours to back a coal plant down. It takes 6 hours to back a natural gas plant down. It takes days to back a nuclear plant down unless you're in an emergency. So wind and solar can be turned on and off, but why if we can store it someplace? So all we're doing is giving the grid operator more tools to be able to make sure our grid remains reliable, and that when I turn on my light switch, there's a high probability the lights are coming on. Where it fits in the big system is battery storage will be located next to a substation. A lot of times it's an existing substation because there's already a grid connection there. Other times they'll build a substation for the BESS. If they're doing like a new solar or a wind farm and they're going to put BESS with it, then it's kind of all built at the same time. But this is how it works. So back here is our energy storage, our BESS. Out here is our grid. And the way that we get battery to grid, it has to go through a process. So battery storage is DC voltage, just like the flashlight batteries in my kitchen drawer, direct current. But that's not what I'm plugged into in the wall outlet, right? That's AC, alternating current. So what has to happen is the battery stores electrochemical energy and it outputs in DC. That DC then gets converted in the inverter to AC. And from there, it gets stepped up typically to 34,500 volts of AC, which is our common collection circuit for any generation source. Sent through some control switchgear, and then over into the actual substation bay, where it's stepped up with another transformer again to match whatever the voltage level is out on the transmission line. Now, battery can also be charged from the grid, and so in that case, the grid voltage is stepped down through the switchgear, stepped down through the transformer. The inverter then takes the AC, turns it back into DC, gives it to the battery, and stores it electrically. That's the 50,000-foot view of how all this fits.
So are all those facilities located in the same place?
Yeah. If they're, so the substation may already be there, and then they'll just add bays to it to house the additional equipment in the batteries. It all looks like a big substation when it's all said and done. All of the BESS equipment uses what's called a ring topology for command and control. There's hardened fiber optics, communications, there's federal security protocols, and I mean, there's so much cyber security hardening and protections in our grid right now. Did you guys hear, just what was the last week, 12 states had their water systems hacked into? There's bad actors out there that are continually trying to get into things to do damage. And infrastructure for energy is one of the most highly protected in cybersecurity. And even then, inside of that communication, there's redundant communication paths so that we can never lose a single failure point and lose communication. And even if we were to lose all of the communication paths all of the battery systems and the control systems are programmed that if they don't have communication to the manned operations center, which we'll talk about in a minute, for a period, it's usually right around 2 minutes or less, they automatically go into shutdown. They put themselves in a safe condition and shut down and wait for somebody to fix the communication. So this is kind of what the typical equipment looks like. On the left is that inverter. That's responsible for taking DC, turning it into AC, or taking AC and making it DC for the battery. One inverter will typically control 3 or 4 battery modules or battery containers. And its sole purpose in life is to communicate with those batteries and kind of understand, can you take a charge, or can I take some of your charge from you? And then the inverter is kind of the gateway that makes the conversions and sends it out on the collection circuit over to the substation. Yeah.
When they put these in, is there a minimum amount of batteries they go with?
Well, it depends on what the developer is looking for. You gotta go back a couple of years. The federal government, and a lot of us never even heard about it, but the federal government, this is 3, 4, maybe 5 years ago now, put out a mandate to the grid operators to say, look, at the rate that consumers or our populace is demanding more and more electricity, we can't build generation that fast. You need to find places on the grid that have capacity to put in storage so that we can start to use things more efficiently and store energy. And so what the developers will do, it takes a lot of studies, a lot of engineers, they're gonna look at these grid lines and these power lines and determine where in the grid that capacity exists. And when they determine where, then they also can identify how much it can take.
And they probably look at over
30
generate
years.
it out, yeah.
30 years.
Because
Yeah,
it don't stay still.
exactly. They're trying to forecast that,
Yeah.
right? And when they identify the spot and the amount, that's when the developer will size the project appropriately.
I'm just wondering if you're, if you come in, say, 3 units, that's their minimum that they'll actually do.
It's usually a little bigger than that.
Well,
for
I don't
utilities.
just,
Yeah,
but,
yeah. There probably is a minimum. I don't.
because I don't think they come in and they're not gonna put in.
If they can't meet what is required to stabilize or supplement the grid in that particular area, then they'll look for a different area.
Okay.
But again, it's they're looking to identify the location on the grid that can receive it, quantify how much it can take, and then design the project.
Now, these have to be at a substation?
Well,
It can be intermediate?
It'll have to have a substation, whether there's an existing one that it can use or they'll build one. Yeah, because in order for us to do what we call interconnect into the grid, there has to be a set of controls and transformers and things, and that's what's in the substation.
And they want it as close to that storage as they can.
Yeah, typically you do, because you don't want long line runs underground, because you get losses, and it becomes problematic too. How many landowners' land are we gonna cross to bury 34,500 volt cable? We do that in wind, and we see a lot of issues with long collection circuits, especially in Michigan, where the frost heave tends to float the cables up over the years, and then a farmer will find it with a plow. It gets a little spicy when that happens.
Especially with them towers they've got out there.
These are great questions, keep them coming. This is a little more of a pictogram I like to use for my fire department family. It's easy for us to kind of understand this when we think about our engine. With our tank of water, that water, the amount of water represents the quantity, how much I have, and then my pump operator can control the amount of flow, that's the power delivery, and that will determine over what period of time can I flow that rate given the quantity that I have. And so basically what's happening here is the battery is my water tank, and it's continually being refilled or recharged and emptied or discharged. And that control valve there, that little spigot, is really the inverter that's turning it on and off, saying, nope, you can have power now, or nope, I need power from you. On the right-hand side, that's a more basic picture of the slide before, where we have our battery and our inverter, our transformer, and on out to the grid. And then you can see on the far right the difference between direct current, which is just at a level, straight line, that orange line, and AC, which is that blue line, and that's what typically our houses, our industries, and things like that operate on. And there's many types of energy storage systems out there, and NFPA actually covers them all in 855, but they do have a special carve-out now for lithium-based technology. But an energy storage system is nothing more than one or more devices that get assembled together that can store energy and then release it at the time that we choose. Ludington Pumping Station, everybody familiar with that? Over in Ludington, Michigan. It's a huge pond, I forget how many tens of thousands of acres it is, at an elevated location, and at night, when there's not a lot of demand for electricity, their wind farm is actually pumping water from Lake Michigan up into that elevated pond. And then during the day where there's a demand, an instantaneous demand, like if it turned 95 out here, we all turned on our air conditioners at once, and it wasn't predicted to be that way, they can open up the gates and run it through a generator and produce electricity for a couple hours. And then they gotta wait and fill it back up again. That's an energy storage system. It's just not very efficient. This is what a typical battery yard might look like on the right. The darker gray containers are the actual battery containers, and then the lighter gray are actually the inverters. And as I said before, one inverter is responsible for 3 to 4 battery containers. The most common configuration that we're seeing today, I actually should update this slide, is what's called a quad. So we'll have 2 containers side by side this way, and then right behind them 2 containers side by side facing the opposite way, so that the doors all work right. And then they'll park the inverter out in front, and they call that a quad configuration. It's still one inverter controlling the 4 batteries.
Is all this equipment sits outside and not in a building?
That's correct, it's outside. It's very rare now to find battery storage systems for utility put inside of a building. Has anybody seen Moss Landing? That's why. Okay. The NFPA is wonderful. NFPA 1 is a beautiful document, but unfortunately, when we put things inside of buildings where people are going to walk into, NFPA mandates sprinkler systems, right? Water and batteries do not mix. And so that's why developers are not doing indoor installations anymore. And the industry has even recognized that and said the better way to do this is outdoors and make it a container that can withstand all of that environment. And then we don't have to do sprinkler systems because they don't work.
When one of these do go haywire, everything they give off is carbon dioxide, hydrogen, yeah.
We wouldn't want it outside.
Everything.
I'd rather have it outside.
Yeah, I don't want that building inside.
Yeah, exactly. And we're going to talk specifically about that. NFPA 68 and 69 both address that, and that's tested under the UL standards now. But yeah, it's much better to have it outdoors. They have built-in setbacks from the batteries to the fence lines. It's typically 50 to 100 feet. It really depends on the battery. And that's the other thing. The battery itself gets certified, and so different manufacturers can have different spaces of setbacks based on the outcomes of the test that we'll show you here in Wyland. So, and it's important for you if you're evaluating a special use permit and the developer brings those materials to you to understand what battery is this, what did the UL 9540 test say, and then those spacings are determined by the live fire test that they have to do to get their certification, and then those spacings get transferred into the project.
Do they have on a site?
I'm sorry?
Do they have on a site like this? Do they have a windsock and everything set up? No. Is it in?
Not necessarily. No. So I do a lot of fire department tactics training across the country. And what I tell fire departments is, take a page out of our confined space and hazmat operations, right? Every one of us has a windsock on the truck. Put a pipe pole up with a piece of caution tape on it. You've got a windsock. And you could do that on your perimeter. So now I could have potentially 3 or 4 apparatus around the perimeter, and I could have a telltale on every one of those apparatus and know what the wind's doing. So windsock you know, you see them, they're required by certain regulations, and you'll see them on certain facilities, but they're not always accurate. They're certainly more accurate than me calling the dispatch center 25 miles away, right? But even the local conditions inside of a plant, or you got big round tanks, you can play with the wind and mess them up too. It's better to just put them around your perimeter. We can talk a little bit about tactics too, if you guys want.
Yeah, for a rule of thumb for sizing, for those I heard, I don't know if this is accurate or not, for like every 10 megawatts of storage, it requires an acre.
Yeah, so each battery container is typically, you can think about it like 1 megawatt.
Okay.
So if you have a 100 megawatt battery, you have 100 containers. And the typical, the average spacing, I'm not going to say it's always going to be this way, because again, it depends on the battery manufacturer and their test results, but usually there's 3 feet between them, and 10 feet off of the ends. So you're talking a 10 acre, 15 acre battery. Yeah. By the time they put in all the other, you got some of this ancillary equipment out here, like auxiliary transformers to run like the blowers and the ventilation systems, things like that.
Well, they got maximum size for the battery storage too, for the units, right?
Yeah, the battery unit themselves, I mean, if you think about a shipping container, these aren't a shipping container, we don't do that anymore, these are purpose designed, but it's 20 feet long, typically 8.5 by 9.5. And the reason we're not likely to see those get any larger individually is because of the weight. The battery containers weigh upwards of 110 to 120,000 pounds each. And so logistics becomes an issue, right?
So is there still lead in those?
No, there's no lead.
What waste?
The lithium iron phosphate, all the battery cells. Yeah. Yeah, they're pretty dense.
And that this technology improves, and all this improves a lot.
Yeah, what we're seeing, the improvements are coming in what we call energy density, right? They're getting more and more energy storage in the same size container as the technology and the control systems continue to evolve into their 6th, 7th, and 8th generations is where we're at now. And that's why NFPA 855 is almost continuously reviewed, is to make sure we're capturing any of that. The other thing to note here, and this comes right out of NFPA 855, you see this system operator down here. 855 requires 24/7, 365 active monitoring by humans. So there is somebody always watching this resource. There's a lot of AI being used to trend things and to look for problematic pieces of data. When people ask me, well, how much data does it spit out, right? I've actually been in a remote operations center down in Florida. I have NERC clearance, I can go in. They are receiving over 500,000 pieces of data per second, continuously. So to expect a human to sort through 500,000 data points every 1 second, right, to look for a trend isn't reasonable. And that's where a lot of internal AI, and this isn't like going out to an AI center and sending data, it's all housed internally in their big servers. They're using AI to crunch those numbers real time to look for problems. And even the control systems that we'll talk about here in a minute, inside this equipment are doing the same thing. They're looking for a problem before it happens. Does anybody understand what we mean when we say a leading or a lagging indicator? Lagging being something that already happened, leading being, hey, I can predict. What's a smoke detector? Is that a leading or a lagging indicator? It's lagging for sure, right? Because in order for the detector to activate, there had to be smoke. Smoke comes from combustion. So smoke detector is always a lagging indicator that a fire has occurred. What 855 did in the revision before this one, and it's continued in this revision, is said you can no longer act on lagging indicators. Your battery management systems, which control the health of the battery, and your energy management system, which is this thing right here, have to be capable of seeing and identifying trends that are leading towards an incident, and then shut the system down before that is allowed to progress to where our lagging indicators take off: smoke detectors, gas detectors, heat detectors. So it's being a very proactive, using leading indicators within the data. And that's why I say the data, there's so much data, they're crunching it all the time.
What's the shutdown time? How long is it?
Instantaneous.
Instantaneous.
Yeah.
Okay.
It's within milliseconds. Everything can be disconnected remotely too. That's the other thing that 855 requires. We'll talk about an incident here briefly, historically, and why that became a requirement. So every single thing in that battery yard can be disconnected remotely by that operations center with just a stroke of a key.
So as regulations are updated, the storage centers that are already out there, do they have to comply? And
typically, you don't go back and comply. We don't do that in a lot of things. So, I mean, you're at the point now with 855, and I don't know if I have the slide in here, but I do know the stats. From 2018 to 2025, 2018 there was 3 gigawatts of battery on our grid. 2025 there's over 53 gigawatts. So that's an exponential increase. In the same period of time though, incidents have fallen more than 98%.
What's the service lifetime?
Typically 25 to 30 years.
So at the end of that time, then they have to comply with whatever the new regulations, if they want to keep going.
If they wanted to, come back and
Or
come back for.
they got to take one of the newer.
Yeah, so so they'll do what's called augmentation. So just like your cell phone, it holds a charge shorter and shorter periods of time as it gets older. That's just a characteristic of batteries. No different here. Over time, those batteries will degrade a couple of percentages. The problem that the operator has is that they are permitted for, let's say, 200 megawatts. At some point, their actual performance is going to be too far below 200 megawatts, so they have to bring in an additional container of the same type to match the system, put it in and plug it in. So when they go for a special use permit and they submit their paperwork, they will show you their intended augmentation. It'll be in the plans and then just kind of grade over and identified as augmentation. So let's say we started with 50 batteries and augmentation says there's 5 additional. Every so many years, the engineers will determine, hey, we need to drop one of those 5 batteries into the augmentation. And it brings the rating back up. We're not going to take a battery that's still 97% good and just replace it all, because that would be silly. So they augment.
So when they bring the new one in, do they take anything away, or they were just adding?
No, they just add.
So it's probably already built into the system, all they got to do is.
It's already built in, everything's done, and it's actually permitted that way.
Right.
So you'll know in the permit how much augmentation they plan on having over that 30-year period.
And that will have the updated standards in it, the new battery that they bring?
It'll have the advantage of updates, yes, but it also has to match their system.
It might not, the new stuff might not be compatible with old stuff, so.
They may be using what we call like new stock, right? Like old new stock, like they bought extra batteries with augmentation in mind. It's same with solar. Solar is a challenge. I'm going to diverge you. Solar is a challenge right now because there's no universal standard on the solar panel, the module, for what kind of power density it has, what the physical dimensions have to be, and so on. And the problem is, let's say all my solar field is 200 watt panels, and I have to replace some of those. I can't put a 400 watt panel in its place. I can't mix it. It's really the same thing with batteries. So when they build a project and they get permitted and they start buying all the stuff, they're buying up their augmentation also and storing it in environmentally controlled storage, usually off-site somewhere.
If these start going in and you've got potentially 20 years apart between one field and another, how is the fire department going to know, like, this one's supposed to be taken care of in a specific way, but this one's more updated? So regardless of what the update is,
it still has to conform to the requirements of the permit.
But I'm saying when our firemen are going in to fight a fire or some sort of an incident, how are they gonna know which types of batteries, what fields? Like you've got 3 of them in here and say they're 10, 20 years apart with new updates. How is that? Are you seeing anything like that?
It's a Macintosh and a Golden Delicious app.
Right.
It's really the same thing. The other piece of that is 855 mandates an annual emergency response plan review with the authority that has jurisdiction, and the fire department also mandates annual training and updates. So they're getting it all the time.
So they have to include the training to us for free then?
Yeah, correct. It's required in NFPA 855. Yes. And you'll see it, it'll be part of the application packet. I write a lot of ERPs, this is why I can speak to ERPs. I write probably 4 ERPs a week right now for fire departments and developers. I usually do the draft for the developer and then tell them, kick that over to the fire chief.
And then you have a training program that you put on too, right?
Yeah, we'll come in and we can come in if we're selected and train your fire department on tactics, right? Not a sales pitch, it's tactics. What to do, how it's going to react, and usually we like to do that a couple of times. We'll do it early on, which is required here, but we'll also do it closer to what's called COD. COD, you'll see in your permit, stands for commercial operation date. That's when the thing is pretty much built. It's the way it's going to be. And then we can really train and test drive the ERP and kick the tires. And going back to what somebody said, we're not seeing these in indoor installations anymore. There's a lot of benefits to the outdoor container. And you can see all of the different layers of protections now that are built into the systems. It'll start at the cell level inside the battery cell, and then those cells are in a module. The module has battery management systems, and we have the enclosures, passive safety systems, active safety systems, and then site level protection and monitoring. So the site level is all your setbacks, your fencing, your security, stuff like that. So it's a multi-layered approach now that's mandated. Also, outdoor gives us natural ventilation. Our separation distances will limit exposure. Radiant heat is really only the primary external hazard. And any gases, like you mentioned earlier, being outdoors are going to dissipate quickly.
So they have self-venting.
Yeah, we're going to talk about it right now. Let's take a dive inside. Over here on the far left is a battery cell, a typical cell. Think about the largest textbook you ever had in school. That's it. It's heavy. This is where the weight comes from. They're about 3.7 volts nominally DC. They'll take a number of those cells and they'll assemble them into this module. The module has a cooling plate, which can either heat or cool, depending on what's required. It'll have sensors for voltage, temperature, states of charge, rates of discharge. Then it'll have what's called an algae cell lining, and that's for heat. That's for thermal insulation to prevent heat from propagating outward if an event happens. And then it's sealed up, and it has a vent on the side so that it doesn't build up pressure. Those modules then get stacked vertically in a rack, typically about 14 of those modules. They're wired up in series. That brings us up to 1,500 volts of DC in the rack. And then the number of racks get installed in the battery container, depending on the design from the manufacturer. You typically see 3 to 4 racks. Those are then connected in parallel, which gives us our current. The container itself then has heating, ventilation, air conditioning. It has a typical fire alarm control panel on the side that we're used to seeing in the fire service. We'll have horns and strobes on the outside of the container. The containers, as I said, are heavy. They're also set on foundations and anchored. Foundations are designed by civil engineers depending on the geotechnics of the soil. Most common is a pylon. So they'll have like 6 pylons underneath of it. They set the container on and bolt it down. Other systems that then get incorporated at the rack level is where the battery management system is employed. That's looking at all of the sensor packages from each individual cell. Its sole purpose in life is to prevent anything bad from happening to the battery cells. As we move over to container, in addition to heating, ventilation, and air conditioning, we have fire safety systems, power controls, blowers, intrinsically safe blowers, motorized louver doors, and then what we call partial deflagration panel on the roof, kind of like a rupture disc.
Now, the stuff on the ventilator, so the gases are any of them toxic, is that an issue?
It's not an issue when as long as the setbacks are done appropriately within the site.
I mean, if you get a massive amount and you get wind blowing, it's gonna carry.
It will, but it's also mixing and dissipating at the same time. And Fire Risk Alliance, which is a world-renowned fire safety engineering company, actually studied 35 best fires where sampling was done, air, soil, and water, almost from the onset, and Moss Landing was one of them. They didn't find any actionable levels outside of the fence line. It was already dissipating that quickly. Hydrogen dissipates rapidly. And in a lithium ion, or a lithium iron phosphate, is predominantly hydrogen. And so it's going to mix and dissipate and dilute very, very rapidly. And then we have our CO2s and our carbon monoxide. The thing is, like when I train fire departments, there's nothing in that smoke that we don't already encounter in residential structure. And here I can quantify exactly what it is because the manufacturer has to provide that information in their desk, right? I am far more worried when I was running calls on the backyard shed fire because I had no idea what was in there. And we're all good consumers and always follow the labels, right? We don't mix chemicals. Those and UPS, FedEx trucks, the trouble breathing medical calls in a house. If you looked underneath people's kitchen sinks, I mean, you talk about risk to the public or to the first responders, there's far more risk that we're exposed to at much higher frequencies than a BESS incident. In a BESS incident, we can quantify it, it's got design standards, it's been tested, and we know what we're going to do going in. We'll talk about that a little later.
Especially if it's mostly hydrogen, because hydrogen mixes with everything.
Yeah, it's hydrogen.
Hydrogen does.
What's the alarm rate on dispatching cell there?
Well, you mean frequency?
Well, if they do have an incident pop up,
Okay,
how
so
quick are they able to?
You're talking about the
Yeah.
operator.
well, the operator's going to know well before you.
Right, because he's got that.
And it, even though it might be even in a different state,
That's right.
they usually have local people.
Yeah, NFPA actually mandates that they have to have site representatives another 2 hours.
Okay.
So
So
typically
they'll
most,
actually meet us out there.
So that
Yeah, or-
invest in DD sometime or consumers.
or most times, again, this is a transparent collaborative process with you and a developer. Well, you'll either get notified early on if there's something going on and they want you out there, or maybe the public calls you and says, I see something, and either way, you're talking to that remote system operator on the phone, even as you're on the way there.
Yeah, because if it notifies them that this could be the problem, I mean, are they going to be able to allow us or notify us beforehand? All right, we're going to need to have you probably get out there. Or...
Yeah, and when I train tactics, this is a defensive only operation.
Right.
You never, ever, ever enter the best yard.
You're gonna be on the road watching.
You're gonna establish a perimeter, monitor your smoke drift, and adjust as required. The only thing
They
that
get them lucky loos out there, and then they want to.
you gotta keep them away. That's right. They want to be the next YouTube wonder. You gotta keep them, protect themselves. So yeah, great questions. Here's a little more of the fire safety system itself. There's also a manual pull station on the containers. There are 2 different color horns. You got your red for your fire, you got your white for gas detection. On the right hand side is what we call deflagration control. Most manufacturers employ both NFPA 68, which is explosion control, and NFPA 69, which is explosion prevention. So one's lagging, one's leading. The lagging, the NFPA 68, is just done with like they call it a partial deflagration panel. It's like a rupture disc. At a certain pressure, it's going to rupture and allow pressure to escape. Sometimes they'll use a weighted door, where the door will crack open, and once the pressure's down, it just falls back down. NFPA 69 uses the gas sensors that are located throughout the container, and at 10% of LEL, it activates the alarms, shuts the batteries down if it hasn't done so already, turns on intrinsically safe blowers, and opens inlets and outlets. And it starts pushing ventilation through the container. And it's an engineered system. And I always tell my firefighter family, firefighters can, and my saying is, dork it up, right? We can really mess this thing up if we do what we typically are used to doing, which is, hey, give me ventilation, all of this stuff. We start opening that container and ventilating it, we have just defeated all of the engineering. We're in experimental territory. We don't want to do that. Let the engineering work, right? That's what it's there for. It will maintain the level below 25% on average in the container throughout the entire event. That's what it's designed to do.
Do they even want you to go in or something like that?
No.
Basically, you just gonna sit there and wait for.
You control the perimeter, monitor your smoke.
Well, I don't want to go in and maybe that stuff anyway.
Right.
It's just like a substation.
Right. It's exactly like a substation. We don't cut the gate fence and go into the substation and start doing things in there. That's not what we're trained or equipped for. So sorry we're getting off on a little bit of fire, but this is a good discussion. You get a sneak peek of some of my training too. Okay, I promised you a little bit of lessons from history. Does anybody need a break, or anybody? I know I can get rambling, so bring me in. I don't know how much time you got before.
I got all day.
Okay, me too. Till 4:30 in the morning when I hop on here.
Okay.
Okay, in 2019 there was an incident in Surprise, Arizona, and this is one that's referenced a lot within the fire service. You can also find all kinds of stuff about it on the internet, which may or may not be true. But basically what happened here is these were a different style container. They were what was called a walk-in container. They were about 40 feet long. And think like, literally they were a 40-foot shipping container that they modified to put racks of batteries inside. And for the operators to disconnect or to do anything, they literally had to walk between racks of batteries inside the container. So, my mind says, probably not a great idea, right? Well, here's the problem. Somebody noticed smoke coming from one of the containers. What do people do when they see smoke? They call the fire service. The fire service showed up. They had no operating procedures. They didn't know anything about the site. They received no training. So, after a little bit of deliberation, I'm assuming with command staff and a chief somewhere, the decision was made to go investigate the source of the smoke. And they did what firefighters do. They walked up to the container, they opened up the doors, and they immediately had an explosion. It blew 2 firefighters 85 feet back through a chain link fence. Everybody survived, and seriously injured the other 2. And that was the point when the industry said, stop. We can't have this technology if this is what's going to happen. So what was done immediately is the industry as a whole, the FDA took a lead on this. They hired a firm called DNVGL. You might be familiar with them. They're a certifier. They do accident investigations around the world. They came in and investigated this incident, and they came up with 5 contributing factors. That the cells had gone into a thermal runaway, which I hate introducing the term before I find it, but here it is. The fire safety system couldn't stop that runaway. The runaway cascaded throughout the entire container because there was no thermal barriers installed. Flammable gases accumulated because they had 0 ventilation provisions. And there was no emergency operating procedures for the site. Okay? We also learned some additional lessons that walk-in closures are not a great idea, and that having to have somebody on site to make disconnects was a drawback. And that the reliance as an industry on the belief that any suppression system could put it out was flawed. So out of that came these standards that you've been hearing about, including UL 1973, which is specifically to the battery cell, UL 9540, NFPA 55, NFPA 6869. And basically what's happened then is the industry has moved to, look, if we can't put it out, and we don't want people opening things up, then the design has to be able to take care of its own problem without human intervention. And so what happened was improved manufacturing and testing, the rigorous testing, including a large-scale fire test. The modules are designed to prevent. They're operating on leading indicators. Most batteries nowadays don't even incorporate any kind of suppression system, and we'll talk about why. Most projects nowadays, in fact, I have not seen a walk-in battery container in the last 4 years. I just don't see them anymore. They're not being used. The other thing that we said that the remote operations center has to have complete control remotely, and even NFPA doesn't recommend active suppression anymore. So big lesson learned right there, and that's, you can attribute and credit that incident to what we have for standards today. Again, we incorporate smoke and flammable gas detectors, fire panels, door switches. These things are locked and secured, special tools and equipment by the technicians to even get in them. Even if a door were to open, it immediately shuts that system down. The one drawback for my fire department friends is even if I shut the battery off, there's still stored energy. Okay? The battery still contains all the energy it has, which is another reason we aren't prepared or equipped to go in and poke around. 1,500 volts will tickle you. Pretty bad.
If you feel it.
Yeah, if you even feel it. Okay, so UL 9540. So you have 855 sitting over here from NFPA, and that is the requirements that the system has to be operated by, perform with, everything that has to take place, even in a worst case scenario, right? UL 9540 is the testing method to prove it. We no longer allow a design engineer or a salesperson to tell us, trust us, it'll work. Have you ever heard that before? Trust me, it's designed to work that way. Now, UL 9540 was brought along hand in hand with 855 to say, 855 says what it has to do, UL proves it. And there's 4 levels of testing that a battery has to go through to be considered for certification. And it starts at the cell level. They'll initiate a thermal event. They'll collect and quantify all the gases and the heat. So we know how much each cell can produce. They'll put that cell together in the module that we looked at earlier. Again, initiate an incident, an event in one of the cells, and watch how it behaves inside the module. From there, they'll do what's called a unit level test. So they have a battery rack, it's in their container, and they'll initiate again in one cell, and then they watch how that propagates through the rack, if it does. But most importantly, they're looking to see that it can't go from one rack to the next rack inside the container. The unit level test on number 3, we're not allowed to use any mitigating factors. We can't use our BMS, or battery management system. We can't use ventilation. We can't do anything. It's the worst case scenario. If they get through that test and it hasn't run away and done anything bad, then they can go ahead and do what's called an installation level test. This is where we can actually use all of our controls and try to stop the event before it happens. If they get through those, then they are qualified to do what's called a large-scale fire test. This is where they'll configure it like it would be in a battery yard. So here's my quad. They'll have the initiating container, and then they'll have target containers around it with temperature sensors and all kinds of instrumentation. And then they're going to initiate the thermal event inside that container. That is a full container just as it's produced. And then they have to make sure it continues to burn throughout the event. If it tries to go out, they have to get it to go again. Excuse me. The other thing that's interesting here is they actually have to have doors and panels open. They have to show a worst case scenario that it happened because it closed. This test specifically determines the required spacing minimums between containers. That spacing minimum is then transferred for that battery model to the site design lines. So if they say you can't be closer than 3 feet or we can't pass this test, then you're not going to see them closer than 3 feet on the site. Okay? All right, so I hate to do that, but I did. So thermal runaway. Thermal runaway, this is what everybody hears about. It's a chemical reaction that's occurring inside the battery cell. It runs unchecked. It's a chemical reaction. Anybody remembers your chemistry class in high school? You put two things together in a beaker and it's going to run its course, right? Like in our chemistry class, we can predict now exactly how that chemical reaction is going to behave and what we can expect. One thing that we will see is an off gas. We have to let the pressure out of the battery module so it can't explode. So we let it out of the module into the container and let our ventilation systems handle it from there. Okay? Thermal runaway can be caused by a couple of things. Ultimately, it's an internal cell failure. Inside the cell, you have an anode and a cathode, and a separator between them in electrolyte. There is no chunk of lithium metal in a battery. It's a lithium ion, and the ion is moving through the electrolyte, and the separator is there to keep the anode from contacting the cathode. If the separator fails, which is what a thermal runaway is, then the lithium ions can move from the cathode to the anode unchecked and release all of their energy in a short period of time. In a nickel manganese cobalt chemistry, it was always violent. It was associated with flames and just billowing and billowing and billowing smoke, and it played out very, very quickly. One of the other reasons that they moved to lithium iron phosphate is we rarely ever see flames associated with it, and it's a much slower and less temperature temperature magnitude when it goes into thermal runaway. The only time we see flames with it is if for some reason it finds an ignition source inside the container. And then, like I tell the fire departments, it's like a natural gas or a propane fire. If the thing's burning and it's coming out of the vents, let it burn. I mean, we don't put out a natural gas or a propane fire until we can control the source of the fuel. Here, if we put out the flames, we're not doing anything for the chemical reaction. It's going to continue to off-gas until it finds an ignition source again. So letting it burn is actually a good strategy. Some of these keys just got the battery manufacturers, as part of that 9540A, are required to produce what's called a hazard mitigation analysis. This is reviewed and signed off by an engineer, actually multiple engineers. And so this is what the developer has as they're starting to put their project together, and you can look at it too. They should be able to provide you a copy of it. But it gives you the actual credible, this is what's going to happen if this model experiences a worst case scenario. And the tests are all designed to say, even in the worst case scenario, with zero human intervention, it stays in one container.
This state what gases are emitted?
Yeah, you'll have a breakdown of the gases. Like for lithium iron phosphate, it's something like 70, I'm trying to remember off the top of my head, like 72, don't quote me, 72% hydrogen, 20% CO2, and then there's trace of other stuff, right, from like the electrolyte things. The big advantage in my mind, if an event were to occur, is with the lithium iron phosphate, they don't have the manganese and the cobalt heavy metals. That those, they precipitate out. Hydrogen just mixes, dilutes, and forms water when it combines with oxygen. CO2 and carbon monoxide we already deal with anyhow, so it just dilutes out.
Do the ventilation systems restrict flow, or they just open up and let it go?
They open up and let it go. The goal of the NFPA 69 strategy is to keep at 25% of the lower explosive limit of hydrogen. So these things are moving some air. They're pushing. And then the remote monitoring systems we talked about, that we've already covered all of this. Thing for like, you know, the AHJs are clearly marked access points, and there's a pre-planned incident command zone where you would stage. So, yeah, just, you know, I guess the thing is there is a lot of noise out there, but understand that utility best is so highly regulated and transparent, and it's a collaborative process between the AHJ and the developer. They can't hide anything. You can demand to see it, and you're creating an ordinance that they'll have to comply with. So, lots of good benefits. I'll open up questions. I got other presentations if you want to get into nitty-gritties and stuff like that. But
Now, is there any electrical, electrical radiation?
No. They have to meet all the FCC requirements for EMF and EMI. I've never even had an issue walking around. I do a lot of work in substations and things like that, and batteries. I could be on a phone call and you can't even tell. So no static on radios. Has to all comply. The other thing too is, we didn't mention it, but there's 4.5 pages of code requirements for electrical systems, including the National Electric Code. They have to comply with too. So,
Just, we were talking earlier, what states are really heavily involved right now with solar and battery storage?
I would say the two biggest states by megawatts being installed are Texas and California. And you can kind of understand why.
They want to go where you're going to get the most sun.
Exactly. And that's the other thing too, and that's kind of a misconception out there now that solar doesn't work in the northern latitudes. The technology does. I'm part of the solar project with my brother up in Mackinac, Sheboygan County, and it's phenomenal production. It's unbelievable what they've done with the solar modules now. And with bifacial, we do a lot of work with companies over in Wisconsin. They use a bifacial panel, so they've got PV cells on the top, just like you normally see. They also have them on the underside, and in areas where they get snow, the top can be totally covered, and they're getting all the reflective energy off of the snow. Yeah, it's amazing.
I was just wondering why they don't put them more like that. See now they're just maybe doing parking lots.
Yeah,
there's park under.
There's a lot of that down south too.
MSU is full of it.
Yeah.
Just
A lot of
the
universities
fact that
own
you
it.
don't take all the farmland.
Yeah. Well, and there's actually, I forget what state they're in, but it's an actual operating farm. I mean, we're talking like 8,000 head of dairy. They're doing, you've heard of like AgriVolt, where they graze sheep and things. What this farm is doing is they're having the developer install them at a height at which the cows can graze under them.
Okay.
And we've known this for years in the wind industry in South Texas. I come down tower and there'll be 150 cows lined up in the shadow of the wind tower, and they're moving with it, right? They're doing the same thing on the panels. They're using them for shade and rest. So I think you're seeing things like that come about. Because one of the concerns is, what are we doing to cropland? Well, I grew up on a dairy farm up in Midland, north of Midland, Michigan. One of the things that family farms are doing is, kids are leaving. They're not coming back to the farm, right? How do I keep my farmland as part of my family legacy if I'm not able to get revenue from farming? And with the cost of fertilizer and fuel and everything else, this is just another crop for them and allows them to keep their land. Now, on the actual agricultural side of it, it also allows for resting of the soil, which makes the soil much more valuable 30 years from now. It's rested, all its nutrients are back. It goes right back into farming, if they wanted to.
Yeah, they move over someplace else, because the life that feels that is done, instead of putting new ones in, and move to another place and bring that back in. Okay.
Yeah, so there's a lot being done with a lot of the concerns that we hear. And I'm I'm not advocating for one energy source or another. It takes all forms of energy production right now to keep up. We are so close to our grid failing because of the demands that we're putting on it without the ability to create more generation. And it's not just the generation, it's transmission lines. I've been on sites across this country that are literally as old as electricity.
We got something, you got that over here?
Yeah.
Carol, do you have a question?
Lines. What?
I'll just see, Carol, did you have a question? I thought I saw your hand up for one. No, I'm sorry.
Great discussion. What else you got for me?
Yes, ma'am.
If I may, and maybe this is something you can't answer, but I just want to, can you respond to a rumor that if they got this battery storage here, it could potentially ruin the whole township, is what some people are saying. It would ruin the farmland and all that kind of stuff.
I don't believe there's any data out there that supports that.
Thank you.
I certainly haven't seen any.
And as far as when you want to do the thing on it, you write it into your code thing that they're responsible for anything that happens.
Yeah, if there is an incident, it's the owner has to do all the cleanup and remediation and properly dispose of the damaged equipment. It goes to licensed recyclers.
And it's just like, if we go out there and set for however long, you just do the same thing when you do DT or anything else.
That's my
After that many hours, you start charging with detailed billing for.
That's a question I have, because we have limited resources in the fire department. So, I mean, how much time would we have to spend on that to be on set?
I mean, I can't say it's an hour, I can't say it's 10 hours or a day or two. But what I can say, because it depends on the incident, depends on the battery. But what I can say is initially the fire service will probably be asked to go establish a control perimeter, right? Monitor smoke and so on. But at the same time, the owner-operator has to be sending incident response teams to the site.
Yeah,
and so
2 hours. So.
Yeah, and so what tends to happen, or what we put into the ERPs, is the fire department's role is going to shift. It'll probably shift fairly early on to more of a, hey, can you just go down there and control that road? Or, you can go back to the station, we got it from here, we'll call you if we need you.
Yeah, kind of like DD does to us now. They
Exactly.
show up and tell us, okay.
Exactly.
Okay.
Yeah, it sounds like it would be a fairly quick response.
It could be.
I mean, yeah.
It could be.
What's the most recent incident that you know about in the new systems? Anything that's a runaway area?
Moss Landing is the big one.
Which one?
Moss Landing happened in January last year.
Can you tell us about?
I mean, I'm not affiliated with anybody that operated the site. They were nickel manganese cobalt batteries. They installed those batteries in an old turbine hall in California. So a turbine hall, if you're not familiar, is where they used to have big turbines that would be run by steam or something, turn generator, right? Massive concrete building. So think about what happens to concrete in sun for hours and hours and hours. So my first thought goes to how are they dealing with the thermal issues? There's a lot of heat in that concrete, right? Being it's nickel manganese cobalt, it's not as tolerant to those thermal temperatures as lithium iron phosphate is. But I can't speak to how they were operating it or, specifically what triggered it. But I do know that one of the contributing factors that I've seen in some of the preliminary reports is it was an occupied building, so they had a sprinkler system activated, and it flooded batteries with water. And it just made the situation worse.
And that's why you see in the newer stuff, they're not doing that anymore.
Right.
And how old was this site?
I don't know the date of COD on that site. Some of the standards were out there, but they chose to do an indoor installation. I don't know for what reason. I speculate, and I hate to speculate. Are you recording me for like broadcast or something? I guess I should clarify.
Listen, this is a good thing to show people.
Okay.
Yeah.
We talked earlier that having access to the grid is one of those important factors when they look to put BESS. Well, if that was a turbine production, for electricity production, there's access.
Okay.
So in my mind, somebody said, hey, we've got this great space and, you know, we'll just stack it full of batteries, and maybe that wasn't a good idea, I don't know. I didn't design it, build it, or break it. But
And
I do know.
that's probably one of the points they bring up when somebody wants to do something like that again. Well, this is what happened here. I don't think you want to do that.
Right, but there was a lot of good that came out of that, because those batteries, they were very early on into UL 9540. They had gone through testing. So the fire service knew exactly what to expect. The challenge comes when all of a sudden we have this overriding standard that requires us to have a sprinkler system, when we know we would rather not have water being flooded on batteries, right? So NFPA 1 kind of gets in the way, and that's why everything's being moved to the outdoors. We don't have that requirement then, and we don't have that issue. But out of that too, I mean, at that site, California, they're a very, you know, progressive state when it comes to their EPA and their testing. So they had almost within, I think it was actually within the first hour, don't quote me, but they had 8 remote monitoring sites set up around there already, including at the elementary schools and surrounding neighborhoods, and at not one time did those go to action levels. So I think it speaks to the standards and the site design requirements.
You know about the emergency response plan that's in place right now, so you know, it's going out, that we could look at or just get an idea.
I'd have to probably get back to you on that, I'm not sure.
Yeah, I don't want to step on toes. If there's one in place that we could look at, that obviously wouldn't be the same as what we would have.
So what I would do is ask a developer, if you get a developer approach you, say, show me an example of an existing ERP. I'll give you that fire chief's phone number.
Well, I know electric vehicles that came out with the ERG, do they have similar for that way? Because I know a lot of the auto manufacturers, they even came out with the new app because there's so many of them out there now.
Yeah, so there's
I know that goes more into the tactics and all that.
Yeah, but we can talk to her. Let's talk, you got it out there. So ERG is their emergency response guidelines, is the yellow DOT book we have to carry in our fire engines. And it's ERG Guide 147 that covers lithium batteries, and it's a big blanket, right?
I didn't know if we could kind of use that same.
It's not the same.
Okay.
It's so over the top because they're taking the absolute worst scenario that they can identify in any lithium battery. So think about electric vehicles, right?
Well, that's right. They don't want us to cut the cutoff switch now, but they have it in there for us to cut. And
this is why 855, when it comes to BESS, utility BESS, requires very specific fire department training. Because even ERG 147 doesn't do a good job. And you know, tactics wise, if you have an electric vehicle that's experiencing this incident in the garage of an occupied wood frame house, my tactics are going to be much different if it's 2 o'clock in the morning.
Right.
I'm going to anticipate there's people in the house. I'm going to make an aggressive offensive attack, do an aggressive search. And actually, you know, we do some partner training with like LA and people like that. There's actually some training programs out there now with to grab that with a J-hook, use the engine to pull that thing out of the garage, and then deal with the structure fire and deal with the car fire separately. Because you're not going to put them out.
Yeah, from the cutter.
I don't know if y'all just saw the news in the Mackinac Island, they banned e-scooters and e-bikes. Last year, they banned them from being inside of an occupied structure because they kept having fires in those things. And now they're just saying, look, we don't even want them, get them out of here. Part of the problem with consumer electronics, and I know before I retired, we had at least 5 fires that were cause of origin from a cordless tool battery left on a charger in a garage. Has anybody gone to replace one of their batteries? I use DeWalt, so I'll just call it out. Has anybody gone to buy a DeWalt battery? Yeah. Are they cheap? No. They're it's almost cheaper to hold a tool kit, right? Get a battery.
Just a battery.
Yeah. So what does the average person that doesn't understand the reason for the cost be? Maybe on Temu or Amazon. Well, look, this same battery, this guy's selling the same battery for $29.95.
Yeah,
It's not the same.
The difference between that battery and the battery from the manufacturer is a 30-cent chip. It's called the battery management system. And it's designed to work with that manufacturer's charger so that those two are communicating just like that inverter and that battery are in the mesh yard to say, hey, I can take some charge or I can't take some charge. Or hey, I'm getting a little hot. You need to shut me off. Okay? The same thing's going on in cell phones. We just had a recent incident in an aircraft where a cell phone went off. People are buying these chargers that didn't come with their phone because they want to be able to recharge their phone in 15 minutes. But their phone was never designed for that. But they can go out and they can buy a charger that will cram as much current as it can push into that battery and create a situation where it can go in the world. So it's the uneducated public out there that I worry about because they just don't understand the risk that they put themselves in.
Also, I heard, I don't know, because of the generation of electricity and everything, these are putting out a loud hum that affects the surrounding area. They're noisy.
As part of the permit process and requirements within, most ordinances, they have to comply with sound, and sound studies are done and things like that. So, that's outside of my purview. I just know that they have to comply with sound requirements and things like that.
55 decibels average rated per hour. Yeah. Yeah, like what we're talking right here.
Yeah.
So if we want to train, how many people do it? Like in the group?
I did 170 2 weeks ago.
I wish.
I did the entire Ohio State Fire Inspection.
We can't bring in the fire department.
We have to get about 5 more guys if we need that number.
Presentation, isn't it?
It's about 2 hours. Sometimes it'll run maybe 2.5. It depends on how interactive the troops want to get.
I know we don't have anything like that out there yet, but let it be tried.
Yeah, we can certainly do that for you. You'll get it. I mean, even if a project's coming, they have to offer it to you. Also.
Yeah.
If you want to just bring me out, then you got to pay.
Yeah. Because there's a lot of good information that just for others.
Yeah.
Type standards and stuff like that here.
Yeah, usually when I'm out doing training, we get not just the fire department, we usually get law enforcement, we get some communities run a separate EMS squads, and we'll get them all.
We get combined communities.
Yeah. Oh yeah. Some of the smaller ones out west, I'll have 6 or 7 departments.
That's what I was wondering, because,
Usually
when I there, then we could let other departments come if they want.
What I would encourage you to do is to, if the developer is going to offer the training, require that all of your mutual aid departments attend with you, if possible.
That makes sense.
Yeah.
It'd be nice if our county association would put it on.
But somebody's gonna go, but they do it.
They could do it and do it right, how they did some of the other ones, right at the picks down the pier.
Any more questions?
Just needs a card from you so we can set something up.
Alright.
And I don't think the fire authority, that's gonna have no problem if we do.
And he has those trainings on YouTube as well. Well, not the trainings he's talking about, but he's got things on YouTube you can watch.
The only one that should be out there is the one from Trash.
Gratiot County, that's the only one I found. So.
That one I kind of got blindsided on. Because I had no idea they were going to do that until I showed up, and it was 5 minutes before. Which is why I asked you.
Well, yes.
That was a quick call to the attorney.
That's good. All right.
Who else? I'll do a couple here.
Yeah, if you do, please. And if you would remember to send that.
Let me go through it and make sure there's nothing in there that gets you in trouble.
Yeah, it's something maybe I could share even with
I think we could do something. I could actually look for that. I did a recording for the state of Michigan's Energy Symposium last year, or the year before, in Franklin.
Yeah.
Because I was out of the country. So they played that video there. So I could probably do that one. It's the same thing.
That'd be awesome. Yeah. I can share that.
Yeah.
Okay.
A little less informal too, you know, with the back and forth and the discussions.
If you don't mind me asking everybody here, what kind of a pricing are we looking at for you to come out and do the training?
I'm thirsty.
I mean, I can send you a fee schedule, but I know.
Yeah, we did,
So,
up to treasure.
that's, you can consider this consultant. So it's $170 an hour on the actual meeting. And we bill travel at $75 an hour. And then mileage at GSA rate, which is 72.5 cents right now. And I'm coming from Columbiaville, so it's like
2.5 hours.
Okay. So maybe I'll be able to get with the guys and see about getting, some of our mutual aid and get together and do a big training.
Yeah, I'd be happy to do that.
Okay.
We're pretty affordable, especially with the right here mission.
Yeah.
If you were in California, that changes things.
Right.
Yeah, they've gotten expensive too.
Yeah, but that's a nice trip.
Yeah. I had to be in Burbank last year with 12 hours notice. So, and then the top, I had to fly from Dallas, Fort Worth, and they're backing our plane out from the gate. They ripped the tip of the wing off. There's only one flight a day in Burbank to DFW. Did you?
Yeah.
I do the, I'm a guest all the time at the California State Fire Marshals Convention.
Thank you, Nate.
So we usually do a good presentation out there. Okay. Nice. Santa Barbara's beautiful.
Oh, yeah, Santa Barbara County.
Yeah, it's good.
It's actually one of the most,
Well, no, I just.
Is it in California?
Might want to.
I wouldn't have guessed that.
when I was there.
Yes.
Okay.
All right, if there's no other questions, let's just, we'll adjourn if you have a few minutes.
Yeah, I'll hang around if anybody wants to talk.
Yeah, I appreciate it. I'm gonna turn the lights on.
Yeah.
That was really interesting.
Thank you. Yeah, sometimes I don't know what to expect going in. I usually find just the best one and then just